Hey guys, so obviously I'm not here and you should be watching this. If you get a chance, go ahead and get this sheet out that I gave you yesterday. I don't know that I have extra copies. I don't know if I'm going to be able to come in the morning to make them. But if you do have it, go ahead and get it out so you guys can check your responses, or you could follow along with some of the work that you may have not been able to do. So, in any case, you do have an exam tomorrow. We do need to be prepared. There will be a problem similar to this on the exam. So, we have a graph here without even reading the situation. It's titled Pool Drainage. We got drainage time in hours as the independent variable graphed on the x-axis, and on the y-axis, the dependent variable, which is water and pool in gallons. And just based off of everything that I see on this graph, I should be able to come up with my own backstory if I wanted to. We're given one here on the left, but really, I know that I have a pool and we're draining it. After 8 hours, it's drained. And then here it says since it starts at 1,200, that's in gallons. That's how much water is in the pool before I start draining it. That's 0 hours have gone by. So, Lucas found a summer job at a pool maintenance company. He is pumping the water from a swimming pool that needs some repair. The graph shows the relationship between the pumping time and the water that remains in the pool. First thing, write a verbal description of the relationship shown in the graph. So, this part's pretty easy. We've done stuff like this before. So, my first thing that I'm going to say here is as the drainage time in hours increases, as the drainage time in hours increases, and then here what the water in the pool decreases. Whoops, spelled that wrong. Decreases. You don't have to get more specific than that based off what it was asking for. If we could find the rate of change, we'd be able to compare how many gallons are being drained per hour, but we haven't done that yet. This next piece actually does ask you to do that. I think I might have changed that piece. I think this piece right here, whoa, make that a little smaller. I think this piece right here was actually, I changed it to something like write an equation that represents the situation. In any case, it's one of these two, or it's either up here or it's down here, but we're going to ask you to write an equation. That's not too hard. That's exactly what we've been doing the last several weeks. Remember, we have y equals mx plus b. That's slope-intercept form. The m represents the slope, and the b represents our y-intercept. Now, our y-intercept is typically our easiest, so we'll start right there. Our b, okay, our y-intercept happens where our graph crosses the y-axis. Again, 1,200 is where it crosses, this graph crosses that y-axis, so that's 1,200. I wouldn't add gallons to that, but just because it makes it messier when we're trying to work with an equation. But so I would just leave it as a number, but understand that represents gallons of water. And the next thing we have to do is we got to calculate our slope. Now, I know it says slope, but don't forget that really we're referencing change in y over change in x, which in this case we're going to look at our rise over our run. You just have to pick two easy points, and the easy points are going to happen at these little tiny intersections like here. A nice one would be looks like right there. It's almost crossing that little intersection. Whoops, I might have moved some stuff. There we go. For this one, the easiest thing to do would be to use this point right here and this point right here, and we're going to calculate our rise. Or in this case, not our rise, we're going down, and our run. Now from here to here, I start at 1,200 and I end up at 0. I went down 1,200 gallons. 1,200 gallons. I know what you guys are thinking. I should go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't write 12. It does go down 12. little boxes or tick marks, however you want to refer to them. But here, every tick mark appears to be worth 100 gallons. So I went down from 1,200 to 0. That's negative 1,200 gallons. I don't know why I put AL. Gallons. Now, I need to look at my run. I'm going from 0 to 8. In this case, each tick mark represents a half hour. So, but I went from 0 to 8, so that's 8 hours. So now, my rise over my run is equal to negative 1,200 divided by 8 hours. For this, you're going to be allowed to use a calculator. Just go ahead and grab a calculator and do this calculation. Negative 1,200 divided by 800 hours. Whoops, not 800. Negative 1,200 divided by 8 hours is negative 150 gallons per hour. That's how much water is being lost every hour, or being drained from the pool every hour. So I'm going to go down here. I'm going to say M is negative 150. Again, don't add the rate. The rate is gallons per hour. We're not going to include those in our equation. So I just got to put the pieces together here. My Y stays as Y. My M is replaced by negative 150. My X is going to stay as X. And this is going to be plus 1,200. So I got my B and I got my M. And that equation represents the number of gallons, which is Y, left after X hours. Okay, next piece. It says, what is the numerical value of the y-intercept for this problem? Well, easy. We already have it. It's 1,200 gallons. That is the y-intercept. That's the y-intercept. And what does the y-intercept mean in the context of the problem? Well, just based off looking at the graph, 0 hours have gone by for drainage time, and there's 1,200 gallons in the pool. 1,200 gallons represents the number of gallons that the pool started with. Before Lucas started draining this pool, there was 1,200 gallons in. That's what the y-intercept is going to represent. This says, what is the zero of the function that represents the situation, and what does the zero mean in the context of this problem situation? We didn't actually go over this. But zero of a function, let me use a different color here. Did we use blue for the slope? No, we didn't. Good. Zero of the function is just another way of saying x-intercept. Zero, this zero, what does this zero mean? What does this x-intercept mean? So they're asking us to not look at the y-intercept, but instead look at the x-intercept. So the x-intercept's happening where this graph right here crosses the x-axis, and it's 8 hours. So what is the zero of the function? What's the x-intercept of the function? That's 8 hours. Now, what does this represent within the situation? Now, let's think. The graph is decreasing, and at 8 hours, I have 0. Once I get to this point, I have 0 gallons left in the pool. What that's telling me is that the pool is going to be drained in exactly 8 hours. So 8 hours. This represents how long it takes to drain the entire pool. Not poop. Pool. Sorry. Use the equation that you found to determine how much water is left in the pool after 6.5 hours. Okay, this is what's going to take you from a level 3 to a level 4. So our equation is y equals negative 150x plus 1,200. What I have to do is identify what this is represented by. Is that an x value or is that a y value? Now remember, our independent variable is in hours, and our dependent variable is in gallons. What they gave us here is an hour. Independent variable is represented by the x. That gets plugged in right there. So what they're asking me to do here is take my 6.5 hours, y equals negative 150 times 6.5 plus 1,200, and figure out how much water is going to be left in the pool after that amount of time. Well, after doing a little bit of calculator work, plus 1,200, my y is equal to 225 gallons. Okay, so after 6.5 hours, 225 gallons will be left in the pool. We can go up to the graph and we can verify that. 6.5 hours is right here. If I go up, I hit the graph here, and if I were to go over, it's about right there, which is almost, I mean, just by visual inspection there, it's about 225 gallons. That's about a quarter of the way to 300, which is right here. Okay, so that's how you do that problem. Now, if they had said after how many hours is, I don't know, something like 400 gallons left in the pool, then you would have taken that number and substituted it into y. Because y represents the number of gallons left in the pool, and 400 would be number of gallons, which would go here, and you'd solve for x. We're not asking you to do that yet. Okay, that's actually coming in the next section when we start solving some equations, actually next trimester. So anyways, hope that helps. If you guys have any questions about the exam, any questions about this problem, I will be at home. I'll be at my laptop doing some work for school. Go ahead and send me an email. If you don't know what that is, I'll write it down. It's cmontes@psd1.org. Go ahead and send me an email and let me know if you guys have any questions or have any concerns. In any case, hope this helps, and I'll talk to you guys soon.